Hi, this is Lisa from biologyforbelievers.com. I am a strong Christian and passionate science teacher who wants to help other Christians learn, not have a fear for science, and learn about biology. In this lesson, we're going to be talking about experimental design again, but we're going to take it up a notch and talk about the null hypothesis. If you haven't already, please check out the previous two videos. The first one was on discovery science, and the second one was on beginning experimental design. Okay, with any experiment, we have an observation. In this case, we were looking at flowers, and we saw that the water turned colors. So we had a few questions that we came up with. Why is the water turning colors? And what would happen if I put a flower in colored water? As we have already discussed, you want to make sure you record your detailed procedures. You want to set up appropriate controls when you're actually doing an experiment. You want to make sure those controls are a white flower and clear water. And we've discussed our variables. Your independent variable is a variable that you change, which in our case was the color of the water. And your dependent variable is a variable that is dependent on the experiment. In our case, was the color of the flower. Does it remain white or does it change? You want to have randomization so you do not have any bias or to make your experiment work. And you want to make sure you have an appropriate sample size. You don't want to be too small, and 30 is about right. So in this video, we want to take it a step further and talk about a null hypothesis. In about high school, you still learn that a hypothesis is an if-then statement. So we came up with, if I put a white carnation in blue colored water, then it will turn blue. In advanced experimental design, your null hypothesis is actually a little bit, it's easier because you're saying nothing happens. So, and the reason why we have a null hypothesis is it's easier to prove that something does not cause a reaction than to prove that something does cause a reaction. And I have two controversial examples. First of all, fracking and earthquakes. For those who live in Oklahoma, like my in-laws do, my husband's family, you will know that since there's been a lot of fracking, there's been so many more earthquakes. But the direct correlation of the cause of fracking to earthquakes has actually yet to be discovered. The next example is called chronic traumatic encephalopathy. Those who have CTE have symptoms of Alzheimer's, and there are a high percentage of football players who have it. Now, not all football players have it, and the only way to prove something like this and to prove that football causes CTE would be to have a healthy brain, have it go through football, and then see that it caused CTE and have it happen multiple times. Unfortunately, that isn't able to work at this time because the only way to actually confirm cases of CTE is through dissecting the brain. Thus, we have not had actual proof, specific proof, that CTE is caused by football. But these are experiments that actually can't be done to have a null hypothesis and to have the data. You can have correlation where it looks like that football causes CTE, but causation is actually very difficult to prove. So going back to our experiment with flowers, our null hypothesis is colored water does not cause any change to the white flower. So think about it. Is that easy to prove? Wrong. Is that statement, null hypothesis, easy to prove wrong? Because the second you have the colored water cause a change to the white flower, you have rejected your null hypothesis and you can build off of that. Because our goal for this experiment is to, when you have a null hypothesis, is to reject your null hypothesis. You want to prove your statement false. Therefore, if we reject it, then the colored water has a high likelihood to cause white flowers to turn colors. So here was our experiment. We had our 15 colored waters with white flowers. Then you have your 15 clear waters as our control with a white flower. In our results, in a perfect world, not 30 out of 30, but 15 out of 15, all of the flowers that are in this side would turn blue. In real life, most of the flowers may turn colors. But what if some of them don't? What makes our experiment a success? If just one changes out of 15, can you say 100% of the time is going to work? No. What about 8 out of 15? 14 out of 15? How do scientists decide what makes a good result? And that's what we call evaluating our null hypothesis. Our null hypothesis was colored water does not cause any change to the white flower. Well, we've proven that's false because we have some blue. It's very subtle, by the way. If you look back here and want to do this experiment yourself, the blue is in the petals and near the center of the flower. So what scientists do is they use statistics to prove that the change was significant. A significant change is 95%. So if you can reject or that your hypothesis 95% of the time, then you can say that your experiment was a success. So what that means with our 15 flowers is actually all 15 of them have to turn colors, because 95% of 15 was 14.7. So all of them have to change. Now, what do we do if only 14 out of the 15 change? Would we call it a success? You have to understand that what a scientist would do is they would publish those results and talk about how they still think that colored water changes the flower, but it's not as statistically significant as they would like it to be. The reason why I'm coming up with this, and I want you to know about null hypotheses and a little bit about statistics, even though I know numbers scare a lot of people. Don't worry, writing essays terrifies me. We all have our fears. But I want to talk about it is because as a Christian, we need to be good evaluators of what is good science and what is not good science. What's a good experiment, what is not. What can have experimental design and a null hypothesis, and what kind of experiments and facts are not able to have that same support. So if you would like to contact me, you can find us at biologyforbelievers.com, or you can send me an email at biologyforbelievers@gmail.com. I will put you on our email list, and every time I get a new video, I will send you a newsletter. I will not release your names to anybody else. Or you can just hit subscribe to my YouTube channel.